Now we're going to look at some of our chain rule with our trig functions and our exponential functions. Now, trig functions in particular are tricky. And the reason they're tricky is because when you're thinking of what's the outside function, whether if I put my arms out like this and I come from left or right, I hit sine, right? If I'm coming from and if I'm thinking about which function I'm coming from, my outside function, I hit sine because when you write sine squared, the 2 goes inside, okay? And so just the notation of sine squared is sometimes confusing. I find sometimes initially this is easier to do if you write it like this, because that means the same thing. And then it's easy to see that our outside function is the squared, and our inside function is sine. Now, if our outside function is the squared, well, the derivative says, the chain rule, do the derivative of that outside function. Subtract 1 from the exponent. I'll write that 1 even though I don't need to. And then multiply by the derivative of the inside function. What's the derivative of sine? Positive or negative cos? Positive. Again, the way that I remember that, I think of my sine graph, I think about my first slopes. My first slopes are going to have positive values, so it's going to have positive cos. I don't know if that helps you remember it or not. So our derivative, if I take away the brackets, is just 2 sine x cos x, which is an identity. That's pretty cool. Oh. This is just pure coincidence that if you accidentally wrote the sine in the wrong spot and then just did the derivative of x squared as 2x, that is pure coincidence that you get the right answer. That isn't some aha moment like we had before with the area of the circle and circumference and volume of sphere and surface area, which is actually nice and cool and true. This is just pure coincidence that it works out. But it's pretty cool that it does. I love it when you can do the wrong math and get the right answer. Right? I've showed you some of those before. Like this. Wrong math. How do you simplify a fraction? Oh, just cancel out the 6's. Everybody knows you can do that. Right? It works. Just in that case. Can't do that always. I've showed you that before, haven't I? How about this one? Have I showed you this one? Okay, solve this equation. Well, just cancel out the ends because everybody knows you can do that. It works. Okay, sorry. Getting off topic. Having too much fun. Ooh. This one has a function inside a function inside a function. Can you see from the outside we have a power, the squared. If we rewrote this so we could see it even better, the very outside function is the 2. Then when we go inside, our next function is cos. But when we look inside of cos, we see another function, which is 5x. So when we're looking inside that function, the smallest one, the 5x, can you take the derivative of 5x? It's 5. Right. Technically, in this last one, we might have said, where is that last one? Yeah, we might have said here, oh, there's a function inside of sine, it's x, but what's the derivative of x? It's just 1, so it's not actually anything that's going to make a difference. Okay, but this one, the derivative of 5x is 5. So we do have an outside function, then another function inside, then another function inside. So with the chain rule, the key is taking one function at a time, doing that law, then looking inside and saying, is there a function inside, and multiplying by it. Then going back to that and saying, is there a function inside, then multiplying by that. Don't do too much at once. Don't try to do too many derivatives at once. So if we look at our outside function when we're doing our derivative, that's our power law. We would start, I'll keep the brackets here just so we can see it, we'd start by doing that. Then what's inside is cos of 5x. What's the derivative of cos? The derivative of cos is negative sine. So we get negative sine of 5x. We're not worried about the 5x yet. Then we go and say, was there a function inside of cos of 5x? Yes, there was a 5x. And we'd multiply by 5. So in the end, we could write this as negative 10 cos 5x sine 5x. And if you wanted to play around with the identity, you could rearrange this further as well. So just for fun later on, see if you can see why that's equal to that. Be a nice show that question. Show that the derivative of cos squared 5x is negative 5 sine 10x. But this would be fine to leave your answer like this second last step. Chain rule is also complicated with e to the x. Okay? When you're looking for a function inside of a function, you have to think, where is the x normally with e to the x? It's in the exponent. So now if there's a function inside of that exponent, that's the function inside of the other function. So what we have to see here, that the 2x squared is inside of the e to the x function. The hardest part about the chain rule is that kind of visualization of deciding what's inside of something else. So if we look at this one and we say the 2x squared is inside of the e to the x function, then our outside function is the e to the x. What is the derivative of e to the x? It's that complicated one. Do you remember it? It's really long. It's e to the x. Excellent. So we start off by doing the derivative of e to the x. It's just itself. So nothing changes. That's the derivative of our outside function. Then we need to multiply by the derivative of our inside function. And our inside function is 2x squared. Derivative of that is 4x. So I'd like you to try this one. All right, how did you do on this one? Outside function is e to the sine x. The inside function is sine x. So there's the derivative of sine x is cos x. And our outside function, the derivative of e to the x is the same, so it stays the same. All right, so if we were doing this one just for fun, probably the first thing I would do is move this all to the top. Oh, you have to watch the end of the video. I'll finish it up on video. You guys can go to your next class. Try it at home and check if your answer's right. So then the negative one would come out in front. Subtract 1 from the exponent. This is what I always have to do with the chain rule. Is move things over because I run out of room. Multiplied by. Inside is another chain rule, but your outside function is a natural log. The derivative of natural log is 1 over. Then what's the function inside a natural log? Sine. Derivative of sine. Is cos e to the x cubed. What's the derivative inside of the sine? Notice how I'm always going back to the original function when I'm looking for what's inside. Don't get caught up looking inside your derivatives insides. So now I'm going to the e to the x cubed, derivative of e to the x cubed. E to the x cubed, then I'd have to look inside of e to the x cubed. There's a function in there which is x cubed, 3x squared, and that's the last function inside. We are done. Now what is the slope of the tangent at x equals 3? All right, see you guys later.